Look who's back! Back from the dead, or back from just being busy with other stuff. Sorry everyone for taking so long before this episode came out. It was summer, it was family, and I have been working on this guy, trying to fix up the wire harness, and it takes so much time, it really does. So it's time to get back on track. And what better thing to get back on track with than fixing my steering column. In one of the previous episodes, I did cover a little bit the basics of my steering column design. Today, I'm going to finalize it, make sure that when I turn this, the wheels actually turn. Okay, let's have a look at where we left off the last time. So we have the cabin, we have our dash, we have all the different things, and then we have a funky looking steering column there in the middle that doesn't look like it's supposed to. Let's get over there and see what this actually is. So this is how this guy looks. My seating position in this car is quite a lot this way compared to the usual way. And also it's a little bit further down. So when I designed this, I designed it so that it was possible to adjust it up and down. So that's what this one does. There's of course this snap-off thing here. Let's see if I can get it on. Like that. It would of course have been possible to just attach this up to the original mounts up here, but then I would have not gotten this ability, and I also wanted to get the supporting point here relatively close to where the bearing is. It's out here, just for stiffness. Let's take it out and have a look at what it consists of. Almost forgot something I need to show you here before I take this guy apart, and that is the upper point. Okay. Fine, it sits around the bar, that's fine. The lower part, the original mounting point on the 964, is just a little brace like that, cylindrical brace, and it's not a tight fit. And I'll explain a little bit later why that is. But essentially what it allows you to do is it moves here, and it actually, down there, it just sits fixated with a little O-ring, so it is actually designed to move. And it has to do with the safety, and it has to do with the fact that if you crash here, it's supposed to be able to move like this. Right, I'll explain that in a second, exactly why it is like that. Here we are, steering rack on the table. I'm going to explain how the original looks, and then we're going to have a look at my little invention here, and we see which one we like. The original one looks like this, sits up in the original mount, like that. So this is just under the dash. And because the 964, the original layout it has, the steering wheel is quite far away from the driver. You have one of these as standard, and then in my car I had an extender. This is actually this is one of these snap-offs, so you can take the steering wheel off. But I had that to get the steering wheel closer to my body. Then you have a universal joint down there and one there, so that this kind of connects the column with the steering rack. Apart from that, you also have a little vibration. I can't remember what it's called, but it's to take away a little bit of vibrations there. So this is all good and all dandy. What I didn't have in this one was the ability to get it closer down, get it closer towards myself, and also I wanted to make it look a little bit nicer. What I didn't cover is the mount down towards the front of the car. This I'm copying for my rack. I'm copying the same way of mounting this as it was in the original. So what you have is this is away from you, right? So up here it's bolted just under the dash. Down here it just sits with a little bracket like this. It's a loose fit, and in that little plastic groove there is an O-ring that sits like this. I'm not going to put it in now because I have to disassemble it to do that. But the O-ring sits in that groove, and then you have a clearance fit here, and the O-ring gets squeezed. So this guy here can't actually move like this. And the reason for this is related to safety. If you bang your body against the steering wheel, it will actually crush in like this. Or it will have the ability to crush in. It will most definitely not do this because of this point, because it's a good fit. So looking at my alternative, what we see here is really just the bearing carrier. So in the bottom, we're going to reuse the exact same mounting method as in the last one. Right, so there's a little half moon in the body, and this little bracket then sits on that, and it has a plastic carrier and then an O-ring. So if you would compress the car, it would do this, right? And that's the way it's supposed to work. That also helps because if you change angle here, it has something to move against there. On this side, we're clamping onto this tube, and we can see that it's open in this end, right? And it's open there so that if you crush yourself into the steering wheel, then it will glide out here and glide in this one here, right? So that's part of the safety concept. Let's look at what this one actually is made of, and then we're going to figure out how long it needs to be so we can cut up the real pieces. This obviously is not the real thing, right? If this is plastic, this is just from my 3D printer just to see that it works. This is also plastic, just a bearing carrier there, and then we take this out like this, right? Okay, so it's just a little roller bearing there, and of course the other side looks exactly the same. Just a little bearing carrier. This one has a little longer sleeve, and the idea when I made this originally was that the sleeve would go under that one, so when you clamp it, you can actually clamp on the sleeve. Then we have the middle pipe here. The middle pipe is actually a sewage pipe. That's not what it's supposed to be in the end. I'm very sure of that. But this was something I had at home, and it had exactly the same dimensions as the piece that is going there. Is what I'm planning to use. Right, so this is just a what do you call it? It's a carbon fiber pipe. Dimensions happen to be exactly what they were on the sewage pipe. So this cost almost nothing. This one is really expensive. So that's why I use this one to just mock up the length. So that, of course, is something that needs to be cut to length. And with that piece cut to the same length as the other one, it will look a little bit like this, right? Still, these bearing carriers are plastic. The intention is that they're made out of aluminum. I'm not going to be able to make them out of aluminum today, but what I will be able to is to print a very durable carbon fiber infused print that I actually think will be strong enough. So I'm going to make one of those, and I'm going to make a test with it. But yeah, it's a pretty simple concept for this. Okay, not so much more to say about the bearing carrier. Next thing is, of course, the steering axle, which is just a 1-inch pipe, steel pipe. Nothing more than that. It has a little collar on it, which the collar, the only purpose with the collar, not color, is to make sure you get a 1-inch hole there, and there's going to be a little screw in this one that stops the axle from moving in and out. So it's just sort of a stopper piece that sits there and makes sure the steering wheel sits where it's supposed to. So with this one attached to the the axle or shaft, whatever we want to call it, we can put these together. And as we put these together, now we have a nicely suspended little steering column, right? I think I might have shown this actually in a previous episode, but of course you need to have a weld end to adapt to the steering pipe there. And then as you put this on in the right place, this one snaps on. And now it sits there without any clearance, and yeah, everything looks good. So I think the next step is to maybe move on to this side and see what I'm going to have here. In the original one we have the two universal joints like this, and this is of course to translate the angle. That's one very important thing. The other very important thing is that if the car crashes, you want to have something here that can sort of move, so the steering column doesn't go up like this as well. So it will come loose, and this will move, right? So how do I come up with something like this? This was very difficult to find. Custom steering joints or universal joints. These are made by, it's a US company, I'll put it in the comments later on. Very long delivery time, unfortunately, very difficult to find. Very difficult to find with exactly the spline dimensions that are needed to fit to the steering rack. So really difficult there. Everything in between is what they call a double D, a 1-inch double D. So that's some sort of semi-standard interface. So with two of these, I can actually piece this together. Okay, so now with these universal joints, I can use something called a weld end. So this is a weld end, double D 1-inch. It's called double D because it's got a D there and it's got a D there, and 1 inch is, I think it goes on a 1-inch pipe or something like that. So if I put one of these in here, and you'll have to press them in. If I put one in there, and then I get this one to fit like that, then I can put another one, another straight pipe in like this, and then I can put another one over here. So now I've created the same thing as I had for the other one, essentially, right? So what I did to try to, because I'm gonna have to put this into the car, assemble it in, to really get a feeling for how long this little middle piece actually needs to be. And once I know that, I will know where to cut this pipe. So my idea is to actually do this, that I pull this pipe out. And once I pull that pipe out, I created a little piece here that will just mimic that pipe sticks out a little bit here. So the only thing this is a little plastic piece that I printed, and then it's a weld end, right? That's all what it is. So with that, I can put the first joint there. Then I need to get to the second joint over here. And then I need something in between here, because this is going to sit on the steering rack, and I need something in between here. I can't put the steel pipe in here because I can't adjust the length. So I created just a little plastic pipe, and then I printed 2 double D ends. So it's just a little piece like this, and I can put that in here, and I can put that in there. And this one can now shift in length. And once I have the length that I think I need, then I can try to measure this in place, like that, and like that. Then I can just try to measure the distance here, and once I know the distance there, then I can cut this one, and then I'll be a happy camper with this piece of the project carried out. And another good shortcut before I get started with this is, of course, look at the people that know what they're doing, and that is Porsche. If I take the original and put the original next to this one, I can see that the joints are pretty much matching up. This side is pretty much matching up. I think where I am with this will take me very close in the first start. Let's go. Okay, so we put this one in there. Got it in again. Looks exactly like it did before. Only difference is that the pipe is now not a sewage pipe, it's something else. I've also tightened it quite a lot now, given it sort of a good position. So even though this is all plastic right now, it is really quite sturdy. And next step is to take our little mock-up piece here and see if we can get it on down there. Come on. Okay. I've been fiddling with this for a while, and it seems to be telling me that the pipe actually needs to be longer. I now have the thing connected. The thing to determine now is if the guy turns, and turns well, that is. If it goes longer in one direction, then the angle on the other direction typically becomes worse, right? And you want the angles to be sort of as even as you can. What you definitely don't want to have is one angle being very extreme, because it won't turn properly. So I'm going to try turning it out and see how it works. I'm not sure actually how I'm going to be turning this. Yeah. I'm trying to see that I get the two angles approximately equal. It's not so easy because it's so difficult to see. I think maybe the angle I have in the top is a little bit too much right now. Playing around, and I think I nailed it. I put a little bit longer pipe now. It looks like the two angles are, yeah, not too far away from each other. But I'm not measuring anything here because it's not so easy. But what I will do now is I will measure the length of it, cut the steel pipe, and put that together. So the idea with this little plastic piece, I think it worked out well. I'll know in the end when I put the other thing together. I have cut this pipe to the length it's supposed to be, and I've done something strange with it as well. I've drilled holes like this. So when I put the weld end into it like this and push it all the way in, I'm gonna have to use the press to do that. Then I have some spots to weld here. And I got recommended from someone that really knows to weld in holes like this rather than to seam weld up here. Because if you seam weld up here, and if the weld ever cracks, you will lose steering completely. If a weld cracks over here, you will notice it, but the whole weld won't give away, so to speak. So I don't know if that makes sense or not. I can see the logic of it, but I was told to do that. So I'm going to put this in. I can't remember if they're supposed to be straight against each other or if I should rotate them 90 degrees, but I'll push it in and then I can just adjust that a little bit later. Put it back, because now I think with just the friction and these couplings, even before I welded it, I think this is going to allow me to feel the steering wheel. Look at this. Let me try. It looks, I mean, it's not welded or anything right now, but it looks pretty sturdy. It looks pretty nice. So this one has enough friction with these ones just being pushed in that I should be able to just see if I can turn the steering wheels with this. And on this side, I know this pipe is too long, so I've just pushed it in just a little bit so that I'm able to get it out later on, so that I can see the length and then cut it. Sorry for all the very strange camera angles here. This is a very difficult place to make a movie from. Ugh. Okay, So we got that one in there. Okay, everything together. It's as sturdy as it will be, considering that everything is plastic right now. It will not be plastic in the end. It does turn. You can see that it's very far out here as well. That's because I haven't cut the steel pipe yet. But it does turn. It does give quite a lot of resistance as well at some certain point, and I don't know if that is coming from the front. I do see that I've made a mistake down there as well. I'll show you here. So when you put universal joints together, it's very important that you face the shafts correctly. And what I've done is I faced them 90 degrees. And what that means is that the length of the shaft will not be constant around a revolution. And I think that's the resistance I'm feeling. So I take it out, show you what I mean, and fix it. This is how an incorrectly faced cardan shaft looks. See this piece here? It goes over there, right? So I'll just fix this, because what this means is that the length of the shaft is not constant over a revolution, and there's nothing that gives in this design. There's no flexibility anywhere, so this needs to be accurate. Okay, here goes take two, this time with correctly faced universal joints. Okay, let's see. Yep, I think that probably took care of that issue. There is some resistance in it, but on the other hand, I have brand new suspension, all bushings, everything is new, so this is the first time they ever turn. So there's bound to be a little bit of resistance there. I could also see in the joints that the double Ds, they were, the fit was not completely 100%, so I might have to work a little bit with the joints to get that really to jive. But have a look. It looks pretty good. I can see I'll have to work a little bit on the alignment of the joints before I weld them, and I'll have to mark them up saying that this is the way they have to sit. And with that concluded, I think it's time to conclude also where the steering wheel is going to be in this level. So I need to get the seat back in here and then just figure out exactly where I cut that one. Pretty interesting concept. I'm pretty happy seeing how this is coming together. Let's get the seat in, cut that, and then we start addressing the strength of this. Whoa. Damn. Okay, we have it there. It feels like it's it feels pretty good now. I really don't like these plastic things that I've installed here. They're no way near as strong as they need to be. So I need to desperately arrange for something there. Now addressing the strength. This concept with two beams like this, it's good of course for forces that go in this direction, but forces that go in this direction, there's not a lot of rigidity in that sense when they're completely parallel. So I changed this around. I brought them out like this. So if you look at this, they now sit with an angle to spread them apart on the bar that they're sitting on. So that means that it's going to be much more rigid this way. I also got a friend to make these in an industrial printer that infuses integral lines of carbon fiber. So that means that this guy here is not actually just plastic. It's plastic with every layer has integral fibers or strings of carbon fibers. So this is supposed to be the same strength as aluminum. I'm gonna put it in there and see how it feels. In the end, I might do aluminum with this anyway, but I still want to give it a shot using all the modern manufacturing ways that I can come up with. Let's give it a go. Okay, new one is in there. Not only does it look a lot cooler, it also probably has a better chance of succeeding. Still not convinced that this can be this kind of manufacturing technology. Aluminum sort of feels like the obvious choice here. So this one has fibers, integral fibers going in a loop like this, and this one as well, going in a loop like this. So I haven't tried to break it. I will try breaking it just in a second here. We see what we feel about it. Okay, first test. It's just like this, and the car is moving more than this one is. And if I do like this, then actually the bearing carrier is moving more than the thing. Yeah, this is a problem. The bearing carriers, they're supposed to be glued in. Let me zoom in a bit. So when it comes to this piece, it is sturdy. You won't feel anything there, but as you can see when you do this, it moves here. So this guy is supposed to be glued into this guy so it can't move. And this one is supposed to be sitting there with the screw into the pipe here so it with the help of friction can't move. Let me take this guy. Now it's moving. Now it's moving. Let me tighten it a bit more. Nah, it's moving. Okay, here we go. So I'm gonna sit here and test drive for a while just to see how this feels. I have realized doing these tests that I need to change some things here from plastic to aluminum. Let's see how much that is going to set me back, because this is not trivial pieces. But you know what? Needs to be safe, so not going to really gamble with what this is made of just to save a few bucks. I have a little bit more work to do with aligning the pieces. I'm making some tools for that. You'll see that if you follow me on Instagram. I'm gonna take some pieces there and just make it fantastically super mega straight so that it feels even smoother than what it is here. Again, very sorry that it took forever for me to get out with another episode. How difficult can it be, really? But I promise you that it won't take just as long for me to get the next episode out. Thank you everyone for watching. If you haven't, press the subscribe button. You know where it is. It makes me happy, which should make you happy. See you next time.